Every economist needs to have a solid foundation in the basics of economic theory and econometrics. It is a dynamic field which involves mathematical and non-mathematical formulations to various economic theories and principles that we study. In this paper, we will focus on the mathematical approach towards economic logic. The mathematical approach is more concise, precise, and keeps us from the pitfalls of an unintentional adoption of unwanted implicit assumptions. Much of economic theory is currently presented in terms of mathematical economic models and economics such as qualitative, stochastic, non-stochastic models. A set of simplified mathematical relationships asserted to clarify assumptions and implications also. Integration, calculus, difference and differential equations, matrix algebra, mathematical programming are used to try these economic models for optimization problems, comparative statistics, dynamic and static analysis. In this module, we try to explain the various applications of integral calculus in the field of economics. We primarily use three major concepts of economics such as the Lorentz curve, Gini coefficient, social welfare in the economy, and transformation of marginal functions into total functions. Integration in economics is the inverse method of differentiation, the process of finding a function fx given its derivatives f-x. Integration in economics is primarily used to find area under the graphs and curves to find the value of shaded area, surplus, welfare, revenue and costs. The sign of integral operation is given. After studying this module, you shall be able to understand the concept of integral calculus and use integration in solving various economic problems. First, we shall discuss about Lorentz curve. The Lorentz curve is a graph of income inequality that shows what percentage of a country's income is being earned by a percentage of country's households. It was developed by Max Otto Lorentz in 1905 for representing income inequality and wealth distribution. The x-axis of Lorentz curve represents cumulative share of people from lower to higher income groups or percentage of households, and the y-axis represents the cumulative share of income earned. Points on the Lorentz curve represent statements like the bottom 20% of all households have 10% of the total income. The line of equality shows a perfectly equal income distribution, that is, x percentage of households earn x percentage of total income. This is depicted by the straight line BD. The closer the Lorentz curve is to the line of equality, the more evenly distributed is the income. The more it sags away, greater is the inequality and uneven distribution of income. The Gini coefficient is a measure of statistical dispersion of income inequality. It is defined as a ratio wherein the numerator is the area between the Lorentz curve and the line of equality, and the denominator is the area beneath the line of equality. Its values ranges between 0 and 1. Here 0 corresponds to perfect income equality and 1 corresponds to perfect income inequality. Example: if the area between the line of perfect equality and Lorentz curve is A and the area under the Lorentz curve is E, then Gini coefficient is A upon A plus E. Since A plus E is 0.5, which implies 2A is equal to 1 minus 2E, that is the Gini coefficient. If the Lorentz curve is represented by the function y is equal to L of x, showing the proportion of total income held by the poorest x% of households, the value of E can be found using the integration E is equal to 0 to 1 L of x dx. Therefore, Gini coefficient will be G is equal to 1 minus 2 integral 0 to 1 L of x dx, which equates to twice of integral 0 to 1 x minus L of x dx. The line of inequality is given by y is equal to x. Example, given L1x is equal to x square and L2x is equal to x plus 2x cube upon 3. Find the Gini coefficient of both the income and distributions. Solution, case 1. Area under the Lorentz curve is equal to integral 0 to 1 x square dx, which is equal to x cube upon 3 ranging from 0 to 1, which is equal to 1 by 3, equal to 0.34. The Gini coefficient is equal to 1 minus 2 integral 0 to 1 x square dx, and g is therefore equal to 1 by 3 equal to 0.34. Area under the Lorentz curve is given by integral 0 to 1 x plus 2x cube upon 3 dx. This is equal to 1 by 3 x square by 2 plus 2 x4 by 4 ranging from 0 to 1. This is equated to 1 by 3 and is equal to 0.34. Similarly, Gini coefficient is equal to 1 minus 2 integral 0 to 1 x plus 2x cube upon 3 dx and is equal to 0.34. Consumer surplus is the difference between the price consumers are willing to pay for a good or a service and the actual price of that good. It is the measure of area between the demand curve and the equilibrium price. It basically represents the benefits consumers get for purchasing good at a price which is lower than the maximum that they are willing to pay. Producer surplus, on the other hand, is the difference between what producers are willing and able to supply for and the price that they actually get. It is measured as the area between the equilibrium price and the supply curve. It is the extra benefit that producers get from selling a product at a price that is higher than their minimum accepted price as shown by the supply curve. Since social welfare in the economy is calculated as a sum of both consumer surplus and producer surplus, we can find society's state of development using integral calculus. Consumer surplus and producer surplus is calculated using supply and demand curves. Assuming that the equilibrium price is PE and equilibrium quantity is QE, then we use demand and supply functions to calculate consumer and producer surplus respectively. Let demand function be DQ and supply function be SQ, then consumer surplus is equal to the integral going from 0 till QE DQ DQ minus PE QE, which is equal to integral of 0 till QE function dq minus PE whole dq. Producer surplus, on the other hand, is equal to the product of PE QE minus integral 0 till QE SQ dq. Example, for a certain good, the demand curve is P equal to dq is equal to 20 upon q plus 1 and supply curve is equal to SQ equal to q plus 2. Find the equilibrium price and quantity, then compute the consumer and producer surplus. Solution, to find the equilibrium quantity, we let dq equal to SQ, that is 20 upon q plus 1 equal to q plus 2. This gives us 0 is equal to q square plus 3q minus 18. The positive solution gives the equilibrium quantity QE equal to 3 and equilibrium price as PE equal to 5. We compute consumer and producer surplus using the following formula. Consumer surplus is equal to integral ranging from 0 till QE dq minus PE dq, which is equal to integral 0 till 3 20 upon q plus 1 minus 5 dq, which is equal to 20 log 4 minus 15 and is approximately equal to 12.73. Similarly, producer surplus is equal to integral ranging from 0 till QE of PE minus SQ dQ, which is equal to integral ranging from 0 to 3, 5 minus Q plus 2 dQ, which is equal to 15 minus 9 by 2 plus 6, getting equated to 4.5. Social welfare in the economy is given by consumer plus producer surplus and is equal to 12.73 plus 4.5 is equal to 17.23. Cost function, total revenue function, marginal propensity to save. It represents the relation between the input prices and the output quantity. Marginal cost is the additional cost spent on producing one more unit of output. MC is equal to dCx upon dx, which formula is for marginal cost, where Cx is a cost function standing for Cx is equal to integral of MC dx plus k. Here k is the constant of integration. Being the constant, it acts like a fixed cost. Marginal cost of producing x units of a product is 5 plus 16x minus 3x square. Total cost of 5 items is 500. Find the total cost function. Solution. MC is given by 5 plus 16x minus 3x square and Cx is equal to integral 5 plus 16x minus 3x square dx. Cx is therefore 5x plus 8x square minus x cube plus k. When x is equal to 5, Cx is 500. Equating these values, we get k equal to 400. Therefore, the total cost function is equal to 5x plus 8x square minus x cube plus 400. It denotes to the sales of a firm based on a quantity of goods. It is the total income of company and is equated by multiplying the quantity of goods sold by the price of the goods. Total revenue Rx and marginal revenue MR is given by MR is equal to d upon dx of Rx and Rx is given by integral MR dx plus k, where k is the constant of integral, representing demand function P is equal to Rx upon x. The marginal revenue function of a commodity is stated as MR is equal to 12 minus 3x square plus 4x. Find the total revenue and the demand function. Solution. MR is equal to 12 minus 3x square plus 4x. R, revenue, is equal to integral of 12 minus 3x square plus 4x dx plus k. R is therefore equal to 12x minus x cube plus 2x square. The constant of integral here is 0. The above function is the revenue function and the demand function is P is equal to Rx upon x given by 12x minus x cube plus 2x square upon x, which is equal to 12 minus 2x plus x square. It is the fraction of a rise in income that is not spent on an increase in consumption. Integration, when used upon marginal propensity to save MPS, helps us to find the savings function. Savings function is given by integral of MPS dy plus c. ds upon dy is equal to 0.3 minus 0.1 y to the power minus 1 by 2. If the aggregate savings function s is nil, then y is equal to 81. Find savings function. Savings function is given by integral of 0.3 minus 0.1 y to the power minus 1 by 2 whole dy, which is equal to 0.3 y minus 0.2 y to the power 1 by 2 plus c. Taking s equal to 0 and y equal to 81 as a solution, we get 0 is equal to 0.3 into 81 minus 0.2 root 81 plus 9.
This gives C equal to minus 22.5. Hence, the desired function is Sy is equal to 0.3y minus 0.2y to the power 1 by 2 minus 22.5.
Let us now summarize what we have learnt in this module. Firstly, integration in economics is the inverse method of differentiation, the process of finding fx given the value of derivative f dash x. Integration in economics is primarily used to find area under graphs and curves to find the value of shaded area, surplus, welfare, revenue and costs. The Lorentz curve is a graph of income inequality and shows what percentage of a country's income is being earned by a percentage of country's households. It was developed by Max Otto Lorentz in 1905 for demonstrating inequality of the wealth distribution. Also, consumer surplus is the difference between price consumers are willing to pay for the good and service and the actual price that they are charged. It is a measure of area between demand curve and the equilibrium price. Producer surplus, on the other hand, is the difference between what producers are willing to and able to supply goods and services and the price that they actually charge. It is measured as the area between equilibrium price and the supply curve. Social welfare in the economy is a measure of total of both consumers and producers' surpluses. So we can find economies, societies, state of development using integral calculus. Consumer surplus and producer surplus is calculated using the supply and demand curves.